video we are going to solve some MCQs question on the types of graph and the handshaking theorem. Now before starting with the MCQs question, let's take a look on a brief type of graphs. Generally, graph means it consists of vertices and edges. And important things we need to note here, this vertices set is always non-empty, means it contains at least one vertex, where edge set can be empty. On the basis of vertices and edges, we have two types of graph, that is the finite graph or infinite graph. Finite graph means both vertex set and edge set is finite. Infinite graph means either vertex set is infinite or edge set is infinite or both are infinite. Further, finite graph is categorized as null graph or trivial graph. Null graph means if we have vertices but no edge, whereas trivial graph is only one vertex in a graph but there is a no edge. If we have more than one vertex in that graph and there is a no edge, that is categorized as a null graph, and total number of vertices in a graph is 1 and there is a no edge, that is a trivial graph. Further, the graph is divided into two parts, that is undirected and directed. Further, undirected graph is categorized into three parts, that is simple graph, multigraph and pseudograph. Simple graph means it contains no multiple edges, no self loop. Multigraph means only multiple edges are allowed. Pseudograph means both multiple edges and self loops are allowed. Further, simple graph is of the 6 types, that is the complete graph, cycle, weave, bipartite, complete bipartite and cube. Here n represents the number of vertices. In cycle we have the condition as n is greater than or equal to 3. Even in weave n is greater than or equal to 3. There is a no notation for the bipartite graph, but there is a complete bipartite graph, and here we have the notation k with two vertex set m and n, and last is cube n, where n represents the bit string of the length n. On the other hand, directed graph is of the two types, that is the simple or multi-directed graph. Simple directed graph means it contains no multiple edges, no self loop, but edges have direction on it. Whereas the multi-directed graph means both the things are allowed, means multiple edges as well as a self loop. Apart from the undirected and directed, we have another category that is called as a mixed graph. Mixed graph means where it contains the directed as well as the undirected edges. Now let's begin with the MCQs. The first question we have, which of the following is true for the multigraph? It is a directed? No. Multigraph is an undirected graph, so discard this. Loops are not allowed? Yes, because in multigraphs only multiple edges are allowed. So it means option B is correct. Multiple edges are allowed? Yes, it may have multiple edges. None of these, hence it is incorrect. So here we have two options that is correct. That is B and C. Next is the complete bipartite graph K, M, N has how many vertices and edges? Complete bipartite. Bipartite means there is a partition. Partition into 2. Now what type of partition we are taking? Basically we are taking the partition of vertices. After that we need to make it as a complete graph. Suppose we have K2, 3. It means 2 vertices in a one set and 3 vertices in another set. Now we need to make it as a complete. As per the bipartite definition, no two vertices are connected in a same set. It means these two vertices does not contain any edge between them. Similarly for these 3 1. Now we need to make it as a complete. It means every vertex of one set is connected to the every vertex of the other set. So here we have the K2, 3 graph. How many vertices we have? That is 5. It means the sum of these two 1. So it means total number of vertices is not the product of this. Hence option A is discarded, option C is discarded. Option B or D is correct. Now how many edges we have? 3 pink edges and 3 green edges. So total edges is 6. Can we relate with this one? Yes, that is a product of 2 and 3. It means total number of edges in a K, M, N is product of m and n. That is on option B. Another question we have, a connected graph with n vertices must have how many edges? Now think, if we have a connected graph, means there is a no disconnectivity in the graph. Let's suppose we take 4 vertices. We need to make connected graph. Right now this is a disconnected one because from this vertex we cannot reach to this one. Let's create a path by the edge. Again it is a disconnected. Let me take a path between the first vertex and the third one. Still it is a disconnected. Let's take a path from third to fourth. Now it is a connected. Connected means there is a way between a vertices. Now is there any way from this vertex to this? Yes. So we can travel to this vertex, then move to this, and then move to the desired vertex. As per this one, this is a connected graph. Total number of vertices are 4. How many edges we have in this case? That is the 3. So minimum 3 edges is required. At least means minimum number of edges must be have in a graph to be a connected one. That is n minus 1. Taking another example, the number of edges in a complete graph is what? Now one procedure is actually you need to remember that. Second, we can drive it. And third, with the help of hit and trial form. Suppose we have the complete graph K2. What does it mean? There are 2 vertices and both are connected by an edge. K3, it is of the form triangle. K4, 4 vertices. First is connected with the second, then third, then fourth. Similarly, second is connected with the third and fourth, and third is connected with fourth. Now it is a complete graph. Total number of vertices are 4, and how many edges we have? 1, 2, 3, 4, 5, 6. Now when we have Kn, total number of edges in that case is what? In K2, how many edges? 1. So surely that is not is equal to 2. As per this one, it says the 2 edges. That is incorrect. According to this, 2 into 1. Again, it is giving as a 2 edges for the K2. Hence, incorrect. In this case, 2 minus 1, that is 1. It may be possible, but we are not sure. For this case, this is 2 into 2 minus 1 by 2. So, again, we are getting 1. Think for the next case, K3. Total number of edges are 3. As per this one, 3 minus 1, 2. It means we can discard this option. Check whether this is correct or not. 3 into 3 minus 1 by 2. That is 3 into 2 by 2. That is equal to 3. So it means only one option is correct. That is D. In general, how to remember the number of edges in a complete graph? What we need to do? We need to find the degree of each vertex. Degree of each vertex in this case, that is 3. Degree means total number of edges incident with that vertex. As in K4, degree of each vertex is 3. It means in Kn, degree of each vertex is n minus 1. So the total degree, that is n minus 1 plus n minus 1 plus n minus 1, so on, that is equal to 2 times of number of edges. Now how many times we have added n minus 1? That is n times. So we can write this is n into n minus 1 is equal to 2 into e. So directly you will get the value of e from here, that is n into n minus 1 by 2. Next we have total number of edges in a wheel graph Wn with n plus 1 vertices. Wn means it is a wheel graph that is formed with the help of cycle. Suppose we take W3. So it means that is formed from the cycle C3. After that we take additional one vertex, connect that with all the vertices of the cycle. The name of this graph is W3. So if we have W4, it means first we need to take a cycle of the 4 length, take additional vertex, connect that with the rest of the vertices of the cycle. As per this, we need to calculate the number of edges. Number of edges in this graph, 1, 2, 3 and 3 inside. So total edges are 6. When we have n is equal to 3, edges count as 6. For this case, here we have n is equal to 4. Here n does not represent the vertices as the vertices count as plus 1. So when we have n as 4, In this case, the edges is equal to what? 1, 2, 3, 4 and 4 inside, that is equal to 8. From here we can observe when we have n is equal to 3, edges are 6. When n is equal to 4, edges are 8. It means it is getting double of the n. So in Wn, total number of edges is equal to 2 times of n. Remember that in this Wn expression, n does not represent the vertices in the wheel graph. It represents the vertices of the cycle. That is represented by Cn. In Wn, total number of vertices is n plus 1, where n vertices of the cycle and one additional vertex that is called as a universal vertex. Next question, number of vertices in Qn. Now what is a Qn? Qn is n cube, or we call it as a hypercube. Always remember the three structures of the cube, especially Q1, Q2 and Q3. Q1 means we have two vertices and the name is 0 and 1. In Q2, we have the square form. It is 0, 0, 0, 1, 1, 0, 1, 1. And Q3 is exactly look like as a cube. And name of the vertices is representing the bit string of the length 3. With the help of these three graphs, we can answer in general what is the expression for the Qn. As per this, we need to count number of vertices. In Q1, how many vertices we have? 2. In Q2, 4. In Q3, 8. Total vertices in Qn is equal to what now? As per this, if we say Qn, it indicates n vertices, but their count is not same. It means discard this. N plus 1, it means 1 plus 1, 2. It is satisfying this one. What about Q2? Is that is 2 plus 1? No, that is 4, not 3. With this, 2 raised to power n minus 1. As per this, 2 raised to power 1 minus 1, that is 1. But total number of vertices are 2. So discard this. So it means D is the correct option. Even you can check it. The power of 2 is increased. Here 2 raised to power 1, 2 square, 2 raised to power 3. So total number of vertices in a Qn is 2 raised to power Next n. Question. Total number of vertices in a Cn, where n greater than or equal to 3. Cn, where n represents the vertices. So Cn is a cycle. Suppose if we take C5. So we have this cycle. Total number of vertices in this case is 5. So in Cn, total number of vertices are n. Next, total number of edges in a Qn. Qn is again nq. So in Q1, how many edges we have? That is only 1. In Q2, how many edges we have? That is equal to 4. In Q3, how many edges we have? That is 12. So here the number of edges are 1, 4 and in this case 12. Check it which one is the correct in this case. Q1, whether it has a 1 square? Yes. Q2, that is a 2 square? Yes. Q3, is that is a 3 square? No. So discard the option number 1. 2 into n. 2 into 1? No. In the next case, 2 raised to power 1? No. And in the last case, 2 raised to power n into n? No. Now, what is the exact count of number of edges in a Qn? It's a very simple. We can derive with the help of handshaking theorem. First, we need to calculate the degree of each vertex. Degree of each vertex in a Q1 is 1. In Q2, 2. In Q3, 3. From here, we can conclude that in Qn, degree of each vertex is n, because when we are dealing with the Q3, degree of each vertex is 3. For Q2, 2. For Q1, 1. For Qn, it is n. Total number of vertices in a Qn, 2 raised to power n. Recently, we have done this. So, total degree of graph, that is equal to n plus n plus n. How many times? That is 2 raised to power n times. So, total degree is 2 raised to power n into n. Now, total degree of the graph is equal to 2 times of number of edges by handshaking theorem. Total edges is equal to 2 raised to power n into n divided by 2. That is equal to 2 raised to power n minus 1 into n. So, in case in the D option, we have n minus 1. Only in that case it is correct. The next question we have, total number of edges in a CN. CN is cycle. In cycle, take example, let's suppose C5. Total number of edges are 5. It means first option is discarded. It says that 2 into 5, 10, and that is also discarded. Option C is correct. But before marking the C option, take one more example because none of these option is there. So if we take C4, total number of edges are 4. In C6, so there will be a 6 edges. So it means C is the correct option. By taking these examples, we can discard the option, and if at the end only one option is left, that is the final Next answer. Question we have, which of the following graph has a bipartite graph? Bipartite graph means we can divide the vertices into the two sets such that no two vertices in a one set are connected with each other by an edge and no two vertices in another set is connected by an edge. In this case, we just need to find which one is a bipartite graph. W6. W6 means there are 6 vertices of the cycle and formed with the help of cycle C6 by taking additional vertex that is connected with all the vertices of the cycle. Now, is this a bipartite graph? No, as this vertex is connected with all the vertices and we cannot make the partition of the vertices. Just take an example, A, B, C. So if I just take these 3 vertices, if I place them in a different set, as A is connected with a B, so we can place in a different set. B is connected with the C, that is placed in a different set. But A and C are connected. Hence, we cannot take the partition of the vertices, due to which wheel graph is not the bipartite graph. Hence, we can also discard the option C. Also remember, there is a trick. If we are getting a triangle in any of the graph, that graph cannot be a bipartite graph. Now we have two options, C5 and C6. Let's check it for the C5, whether that is a bipartite graph or not. Here we have taken the C5 graph. Let's make the partition of the vertices. A and B are connected, so we place them into the different set. B is connected with C, so place it into the different set. C is connected with D, place it into the different set. D is connected with E, so it cannot be in the same set, so place here. E is connected with A, but they are in a same set. Due to this, C5 is not a bipartite graph. Hence, D option is correct, but we can also verify that whether this is correct or not. Here I have taken the 6th vertex in a C5 and that converted into the C6 graph. As D is connected with E, so we have placed in a different set. Now, E is connected with F, so that should be placed in a different set. F is connected with A and that is already placed in a different set. So it means we can make the partition of vertices, take a vertices A, C, E in a one set, B, D, F in another set, and none of the vertices in this set are connected with each other even in this case. Hence we get the partition of the vertices, due to which C6 is the bipartite graph. Taking one more example, the chromatic number of bipartite graph Km, N is what? Chromatic number means minimum number of color used to color the vertices such that no two adjacent vertices have a same color. As it is a bipartite graph, it means we have the partition of vertices and no two adjacent vertices are lying in a same set. It means we can color each vertex in a one set with one color. Let's suppose it is a red, and all vertices placed in this set as the another color. Let's suppose blue. It means total number of color used in this case is 2. So whenever we have any bipartite graph, the chromatic number of that bipartite graph is always 2. Even in the previous case, C6 is a bipartite graph. You can check it, total number of color used in this case is 2. Suppose we have assigned this as a blue. Now we cannot assign this vertex as a blue, but we can assign the vertex C as a blue color. D cannot be a blue because that is adjacent with C, but we can assign E as a blue color. All the vertices placed in a one set has a blue color, whereas other vertices have a pink color. So total color used in this case is 2.